The parabola of a quadratic expression will open upward and have a minimum point when a, or the coefficient in front of the quadratic term, is positive, and will open downward and have a maximum point when a is negative. So we have our curve, and when a quadratic has a positive coefficient, we know that it opens upward towards positive infinity of the range and then has a minimum point. This minimum point has a coordinate of hk. The h is the x value of this point, and k represents the y value at this point. So the range will be from the y value k to positive infinity. And I'll show you why we're using this notation in a second. If we had negative a in front of x squared, the function would flip and would be opening downward towards negative infinity of the range. So this here is a maximum, where it's the highest point of the function. And this maximum point has an x coordinate of h and a y coordinate of k. So the range is from negative infinity all the way up to k. Now, why are we using h and k? H is the x coordinate of the point that we are looking for, and it can be found using this formula. H is equal to negative b divided by 2a. A is the coefficient of the quadratic term, and b is the coefficient of the x term that has an exponent of 1. So the minimum or maximum point of a parabola is called the vertex, and it can be calculated using the coefficients from the expression. So the x-coordinate, h, is equal to negative b over 2a. That allows us to find the x-coordinate, and then we plug that value into the function, and that will allow us to find the y value at this point. So this y value k will be the low point or the high point of the parabola, and thus the range. Let's walk through an example together. Let's say you were asked to find the range of f of x, which is equal to 3x squared minus 4x plus 3. So we want to use the coefficients to first calculate h. So we have h is equal to negative b over 2a. So b is negative 4, and a is 3. So now we can simplify this to find h. Negative times a negative is positive. And we have 4 over 2 times 3, which would be 6. 4 over 6 can be simplified to 2/3. So we have h is equal to 2/3. So now we want to solve for f of h, and h is 2/3. So we'll plug that in here for our x's. So that would give us f of 2/3 is equal to 3 times 2/3 squared minus 4 times 2/3 plus 3. So that gives us 2/3 squared, which is here. This 3 is technically in the numerator, so we can cancel out one of the 3's in the denominator, so we'll cancel out this one. So that leaves us with 2 times 2, which is 4 over 3. And now for the second term, we have negative 4 times 2, which would give us negative 8 over 3. So since both of these terms have a denominator of 3, we want to change this third term to a denominator of 3 so that we can simplify the expression. So 3 is equivalent to 9 over 3. 9 divided by 3 gives us 3. So now we can combine the terms. 4 minus 8 is negative 4, plus 9 would give us 5 over 3. So f of h is equal to k, or the y value we are looking for, and that's equal to 5/3. So now that we know that k is equal to 5/3, we can find the range, but we first want to evaluate the sign in front of the quadratic, and it is positive. So that lets us know that the quadratic is opening upwards towards positive infinity as its high point of the range. So the range is from 5/3 to positive infinity, including 5/3. So that is how you go about finding the range of a quadratic that is a trinomial. Let's now have you try a few practice questions. Question number 1. Find the range of f of x, which is equal to 2x squared plus 6x minus 1. Question number 2. Find the range of g of x, which is equal to negative 3x squared minus 6x plus 9. In question number 3, find the range of h of x, which is equal to negative 5x squared plus 10x plus 4. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. F of x is equal to 2x squared plus 6x minus 1. So we are first going to calculate h using the coefficients 2, which is our a, and 6, which is our b. So h is equal to negative 6 over 2 times 2, which is 4. Negative 6 over 4 can be simplified to negative 3 over 2. And 3 over 2 is 1.5. So we get h is equal to negative 1.5. So now that we know h, we can solve for f of h, or f of negative 1.5. So we plug that in for x into the function, giving us 2 times negative 1.5 squared, which is 2.25, plus 6 times negative 1.5, which is negative 9, minus 1. 2 times 2.25 is 4.5. 4.5 minus 9 is negative 4.5. Minus 1 is negative 5.5. So our k is equal to negative 5.5. So this is the y value we are looking for. And now step 3, evaluate the sign in front of the quadratic. It is positive. That lets us know the quadratic is opening upwards towards positive infinity as its high point of the range. So the range is from negative 5.5 up to positive infinity, including negative 5.5. So that is the answer to question number 1. Let's now have a look at question number 2. G of x is equal to negative 3x squared minus 6x plus 9. Step 1, calculate h using the coefficients negative 3, which is our a, and negative 6, which is our b. Negative 1 times negative 1 will give us positive 1. So we wind up with a negative from this negative. And we get 2 times 3, so we get 6 in the denominator. So we wind up with negative 6 over 6, which is negative 1. So now that we know h is equal to negative 1, we can solve for g of negative 1. So we plug negative 1 in for x, giving us negative 3 times negative 1 squared, which is positive 1, times negative 3, which is negative 3. Negative 6 times negative 1 is positive 6, plus 9. Negative 3 plus 6 is 3, plus 9 would be 12. So we get k is equal to 12. So we need to evaluate the sign in front of the quadratic, and we see that it's negative, which lets us know the quadratic or the function is going to trend down towards negative infinity as its low point. So once we know the graph is going to open downward towards negative infinity as its low point, and we have 12 as its high point of the range, that lets us know the range is from negative infinity to positive 12, including positive 12. So that is the answer to question number 2. Let's now have a look at question number 3. H of x is equal to negative 5x squared plus 10x plus 4. So we are first going to use the coefficients negative 5 and 10 to calculate h. So h is equal to negative 10 over 2 times negative 5, which would be negative 10. This negative and this negative cancel each other out. So we get 10 over 10, which is 1. So now that we have h is equal to 1, we want to find h of 1. So we plug in 1 for x, giving us negative 5 times 1 squared, which is negative 5, plus 10 times 1, which is 10, plus 4. Negative 5 plus 10 is positive 5. Plus 4 would be 9. So we know k is equal to 9. So now we want to evaluate the sign in front of the quadratic, and it is negative, letting us know the function will open downward towards negative infinity as its low point, and 9 as its high point of the range. So the range for question number 3 is from negative infinity to positive 9, including positive 9.